figured before we jumped into Excel and spent a lot of time, I wanted to show you the main components of this first part, which is to calculate the first two, the last two, and the summation and the number duplication test. So we're getting a lot done here, and I wanted to give you some concept of what we're doing before we jump into it. So first off, one of the main things that we're going to have to learn are the two formulas that you see here, and what will be, I would copy these word for word if you could, as you're building your first and last type of calculations. Now we'll be using the round function, absolute value, the left function, the value function, and that will calculate either first two digit or last two digit. And then when we do the last two digit, the only thing we're switching out in the calculation is the left for the right. So we're going to be going based on the right of the number, so the last two digits or the right of the numbers will be used in that calculation. So now just moving on to the next slide. The summation test is another test that we're going to do, instead of the first two, last two. And it's similar. We are, going to be taking a look at it, but we're looking at the percentage of the summed values in each one of these categories. So normally when we take a look at Benford's law, we're looking at the count of the values, and in this particular test we're taking a look at the summation, or the sum of those values, and it'll make a lot more sense when you look at it. But I love this example that Mark Negrini used in our last webinar, where in this Wall Street Journal article he was expecting a $513 tax return, and instead he got a letter informing him of $300 million, and it was or $300 million. It was mind-boggling. And if we had taken a look at the digit patterns at the 30 mark and took a look at the percentage of the total value that was summed, in that point, especially given the fact that it sounds like many more people were given this $300 million check. It wasn't just one person. So the summation test would have found that, and again, you'll see that as we go through the example, but I thought this was just a great example of that. And what we're going to be using to kind of summarize everything up, so first we're going to calculate a first two digit, last two digit, whatever, and then we're going to be using pivot tables, and pivot tables have really advanced. I'm going to be showing this to you in Excel 2007, but you could also work in Excel 2007 or 10. You still could even go back to 2003, and I find that they're still powerful there, but they really have advanced some of the features and some of the usability of pivot tables in the later versions. So we'll be going to the Insert menu, selecting our data, and inserting a pivot table, and that's kind of how you get to that slide there. Then in getting around the pivot, you have the pivot table tools, which are at the top there of the actual menu bar, or ribbon as they call it now, and that allows you to get to a lot of different techniques or functions within Excel that you could utilize to update your data. So you could either right click your data, or you can use this design options up top there to change, say, the amount values and how things look, and other types of design options to make things look even prettier. What I find is if you do right click a value and want to change the number format and type, this is what we're going to be doing quite a bit. You can then summarize values, count values. You can show values as a certain, in this case, currency, but also as a percentage of, say, a column or percentage of a row. And again, we'll be showing that quite a bit. So I wanted to have these pictures for you so that you could refer back to them. But we'll be using a lot of these examples in the coming few minutes. Now, I developed this Excel spreadsheet so that you can utilize this for your own needs. You'll obviously need to switch out your own data for the data in here, but it does give you a very nice model of not only calculating the basic Benford test that we're about to do now, but later we'll talk about doing a scoring and other types of charting of that information. So first off, though, let's take a look at doing some of the basic Benford tests, and I'm going to be working within these sheets right here. And these sheets are quite nice in that you can actually click on them and be brought right to the sheet. This is from the index sheet here, so that you can kind of remember, because there are a lot of sheets to take a look at here today. This will be a good way of getting back and forth. But in this Benford type test, what we have here is our data. And within our data here, this is supplier information, where we have the supplier number, the enter date, the actual amount, and this is what we will be calculating our Benford law on. And I came up with a record number as well, just to kind of keep track of the records themselves. It's always a good idea to put that in there, and if you don't have one. Now, let's talk about some of these calculated fields that I've now created, which I've put yellow on top of, just so that you kind of know that they're calculated. The first one is the year of the enter date. So D2 here is the year, and if you click on that function, it's basically, returns the year of a date, an integer in the range, and I believe there's a day and a month if you care to ever get the day and the month. But in this case, you'll see why this year is very important, and why we'll be using that field. The second one is a little more complex, as I noted in the slide, and why I would suggest that you just copy this. But let me explain, what are we doing here? What is going on in this particular? Yeah, see, I can't even bring that up as a function. It's so complex. So let's take a look at it piece by piece. We're taking the E2 value, which is the amount value, and we're multiplying it by 1,000. And the reason we do that is just to get rid of, in this particular case, say in the 5.00, that's going to make it 5,000. What you're able to then do is much more quickly calculate that first two digit off of that number. We're going to then get an absolute value of that, just to get around any negative values that would show up in the first two. So you don't want to have a -5 here. That's just annoying. Instead, we're just going to turn everything into a positive number. We're then going to do a round of that number, just to keep it in a round format. And then we're going to take the left one, which is this left one, and that leads to the final value at the end that we're then calculating as a particular value, so that you could sort it from high to low, and it'll actually sort like a value. So there's a lot going on here. My suggestion to you again is just to follow the actual formula, as opposed to breaking it up too much. I've tried my best to explain it here today, but I would just say use it. And then moving on to the first two in this case, everything is the same as the first one. The only difference here is this little digit right there. So it just changes from a 1 to a 2. Everything else is the same. Last but not least, the last two, we're actually going to calculate now. The only difference here, instead of it being the first two and last two, the only difference here is the word left. So instead of it being left, instead of it being left there, we now have right over here. And the right will calculate the right two digits. So from the right, it'll go backwards by 2 and get to that 37 that we're looking at here. So again, the 197, the first digit is a 1, the first two digits is 19, and the last two digits 37. In this 5 number, again, we have 550, and then the last two being 0. In this case, if it's 00, it shows up as 0, and that's okay for our purposes. But anything else, be it any sort of two digits that you would get, you'll end up getting as two digits. So that's our first two and last two and entered year. This is all we need to calculate. And then as we go back to our index here, the first pivot, the first two, this little chart, the number duplication, all of that is going to work off of pivot tables, which we'll now show you how to develop. While we've already calculated the pivot tables, I wanted to make one pivot table with you so that you understood the concept well. And what we could do is we're going to go to our Insert menu and select Pivot Table. Now, more than likely, Excel will calculate your Benford data A1 to 91,354. You might have to select it by clicking there and then selecting the data, but assuming you're okay with the way it's come up with, we're then going to go to a new worksheet with that particular pivot table. So let's do that. And now that I'm in this pivot table, I have a few options here. I'm just going to try to drag this up a little bit so you can see it a little bit better. And what I can then do is start dragging information from this little wizard over here over into my pivot table there. Now, there are a lot of different ways to do it. You could use the pivot table tools up here to do it. You could, but this I find is the easiest. Let's drag over the first one and we'll bring that into, let me just click on that. And it automatically calculates that as opposed to bringing it into my rows. And I really want to bring that into the rows. Now, again, there's no negative numbers here. It's something where it sorts from high to low because it's a value, so Excel knows to sort it from high to low. What I'm then going to do is bring the entered year. Let me just make it simple here. I'm just going to drag it from here into this column area. And now I have 2008, 2009, a grand total. I'm not a big fan of the grand total, so what you can do is you could select in your pivot table tools, you could select your options, and then you have a totals and filter, and you can get rid of your grand totals for rows, grand totals for columns, however you want to do it. I usually get rid of the grand total for rows, so that now I just have 2008 and 2009 over here. If you ever get rid of that field list window, you can select anywhere in the pivot table and it should come back up for you. Another way is to go back up here and get your field list there. Okay, so now it kind of gets fun. So what we want to do is bring, as crazy as this sounds, the first one into the values category. And what that'll do is, this case, it summarized that, so that's not exactly right. What we want to do is go to Value Field Settings and select Count. And in this case, we're getting a count of the first one within each one of these particular categories. Now, while that's interesting, I mean, to look at, okay, what was the total numbers within the count of how many items started with a 4,716. How many items started with a 5, 4,340 in 2008. And again, just to go back to our data so you see this, it's basing the column off the 2008, 2009. And if you go down in your data, you'll notice 2009 starts at about the 49,000 mark. So you can kind of go back to this sheet that we calculated at 48,351. That's where 2009 starts, and then it goes for another 43,000 items. But because there's differences in the number of items by about 5,000 especially, what I like to do is do this on percentages. So we go to Value Field Settings, Show Value As, and say percentage of column. So we're going to show Summarize On, Count, Show Values As, percentage of column. And now each column is 100%, and because that the count, again 48,000 versus 43, that gets removed, and you notice how remarkably the same it is across the board. I mean, it's like 0.03 off on the digit pattern 8 or 7 or 6 or 5, and that's what's really amazing about not so much Benford's law in this case, but just digit patterns in general, because we haven't even incorporated Benford law into this analysis yet. So again, this was just kind of calculating a percentage of the count in each year by the first digit. Okay, so let me go over the first pivot that we've calculated for you. And in this case, I have both. I have not only the count of the first digit, but I also have the sum of the amounts within that first digit. So let's take a look at that sum of amount here. Let's just, for fun here, change the value field settings, and instead of showing it as a percentage, I'm just going to say normal. Just give me the total here. And that's going to give you the total value that's within that field. So it's it's like $1 billion or something that is in here, and it's $318 million of items that start with a 1 and etc. But again, I don't like looking at it in a dollar sense. I like looking at it in a percentage sense, because that's really what we care about. So percentage of column, boom. So that now we're back to this percentage of column. Now what's interesting is we talked about the summation test. This right here is your summation test on the first digit of numbers. And if you had that $30 or $300 million being paid to 3,000 people, you would notice, and actually it's kind of coincidental that in this particular time frame, at the 3 mark, especially 2009 versus 2008, you have a noticeable jump in the percentage of values that are showing up in that digit pattern. So again, based on count, the count is about the same. It's only zero point 0.8 off here when you take a look at the count. But when you look at it from a summation point of view, you're actually looking at about a 5% or more spread there, which was really remarkable because no numbers, when you look at it from a count perspective, just going back to this one, there's not one number here that's off by 5%. But again, when you look at it on the summation side, you start to find that. So that's what's interesting about the summation test as we go into it. But again, what I've done here is I've just added another column. I've brought down sort of another column into this item here based on the sum. Let me just go back into this. So this is the sum of the amount that is in there. So it's sum as opposed to count. And we show values as percentage of column. So it's not, it's pretty simple once you get started with pivot tables and getting going to start building pretty complex things. And the nice thing about the pivot is it does a lot of the work for you. First to pivot is where now, instead of me calculating off of the first digit, which is that first 1, we're now calculating off of the first 2. So that's that first 2 here. But everything else is pretty much the same, as you notice here. So that's what's kind of interesting. And this is the one that I ended up graphing. So let's go back to this first pivot. You could have graphed, let's say we're doing an audit of 2009 versus 2008. And that's most of what we're going to be talking about today. Notice how we could take the summation test for 2009 alone and just take a look at what looks weird and what looks off base. But what I find is when doing that, it makes a lot more sense to bring in last year's numbers to that. Okay, so with that said, we go to the first 2 pivot, and in this case, we can take a look at the summation test count of 2009, and actually, in this case, it isn't count of 2009, it really is the sum of 2009. And as you notice here, you see sum of amount, and that's the sum of the 2009 amount here, so that's right here. So that's as we talked about. And based on that summation test, we have 10 through 99, and we have the percentage, which this will all add up to 100. Notice the 100 down here. So that is basically the percentage of items that have a 10, percentage of items have a 11, and this is the total summed value that is showing up in each. You can easily chart this information by highlighting these values here and inserting a line chart, a bar chart. In this case, I think we ended up doing a column chart actually, and we just did a very simple 2D column chart. And that 2D column chart is listed here. And wouldn't you know it, as you look at these digit patterns, I mean, things look pretty, normal, I guess, across. I mean, there's a few items sticking out here, but let me just kind of drill into this. Look at that, 3, 9. So we said back here on the first pivot that the number 3 was kind of weird, especially when you looked at last year. But even when you look at it just in totality, when you look at it just for that given year of time, the 3.9 has a 5% versus everything else that's like 2 or 3%. So again, this one's way up there at 5%. And what's really nice about pivot tables, so I've already kind of done this over here with the 3.9s, but what you can easily do is once you realize, okay, I have something to go look at now, I can go to this 3.9, the 5% in the pivot table, double click on that, and it brings me that data, and that's actually what we have here. And when I double clicked on that and got to the detailed data, what I noticed was that I just highlighted a few of them. There's a lot of $3,900 items and a lot of $39,000 items in there. So you can see that's like 3,900, 39,000 throughout the data itself. So it's very, quite interesting to take a look at and see how not only by calculating a first digit, a first 2 digit, and this summation of the first 2 digits, you can learn a lot, but also very quickly just by charting, one situation here, the summation test, very quickly you can see that 39, double click on it in the pivot table and get to all of the details of that 39. Now, in the interest of time, I just wanted to show two other pivot tables that we've created. And one of them is the last two pivot, which is the last two digits. Again, it should be 0 to 99 if you have all those. And I've then done that based on the count of, and that is over the time frames of 2008, 2009. So I really followed the same thing that we've done in, say, the first pivot or first two pivot, but I've just used the last two digits. And you'll see as this becomes important, but this can be useful in taking a look for round dollar values, which again, this year to last year looks really consistent, so not a big deal. A lot of times 50 is another one, it's kind of like a round value, it looks pretty consistent though. And then also 75. And again, what I find so remarkable as you look at these values across time frames is that the difference between year one, year two, and probably if you had 5 years here across the board, it would be very, very consistent. Another test that we like to run, and this one I'm going to actually show you how to make it because I think it's kind of neat, is you actually do a pivot table on the value right here, the amount value itself. So let's go insert pivot table. We'll just do this quickly, interest of time here, and take the amount field, and I'm going to bring that over into the row area. So now this shows every amount that is in your data, and then what you could do is bring on into the values section, you can do a count of those amounts, and again, maybe do like a percentage of column, because I find percentages makes it a lot nicer to look at. And you have a lot of zeros there because you don't really have a lot of these things showing up, right? I mean, it's showing up in a very minimalistic way. So what you can do if this is happening in your particular data, if the count of those amounts is not that high, you can go to the value field settings and you could go to number format, and instead of it being 2 decimal places, you could make it say 5 decimal places. And that should help you to kind of see the relative differences or size. If you wanted to see the count of that amount again, we can just just for argument's sake here, just add a count field in here to see how many are 1 and how many are showing up more often than not. This is useful because then you see all the ones, and that is going to happen a lot. But you could go right up to your pivot table tools options, sort, and you could do largest to smallest in this particular case. And because I'm highlighted on that field, it should work for us. It's taking its time here. And what we should be then doing is then sorting on the count of that amount too, from a high to low fashion. And in this case, we have the $50 showing up 651 times, the $100 showing up 604 times. And once again, very similar to before, you can just double click on any of these and get right down to, okay, what happened here, and that gets us right into that data. So let me just try to go back here. So this was the number duplication test we had. I have created one for you to utilize as well. Here's number duplication, where it's looking at not only the count from year to year, which we broke it up in 08 and 09, but also the percentage of the count from 08 to 09. And again, I find that remarkably similar from year to year. It's only off by a few percentage points in any one given value within a given year.